Ledge Runner Part 4. In this lesson we will have to handle the special collision detection. I will show you the concept of heat detection prediction for how do they call it, bounding boxes that are axis aligned, axis aligned bounding boxes, yeah, but with prediction. I'll show you visually how it works, but let me show you how the function should look like what it should get first. It won't be an easy concept, but let's try and explain it to you. You know, in worst case, if you don't understand, you can contact me or research the topic on your own. I learned it from researching. Let's see, so we'll need to get the ID of the entity you want to check collision with the second entity. So ID 1, let's say the player, with a ledge. This can be like for anything, it's a function that can be used in any game. AppGameKit doesn't have heat detection prediction by default, but their functions are very helpful. They do have rectangular collisions, so I can work with that. And then X prediction, which is a float. The prediction from the X bounding box, like if you're going to hit from the left or from the right, it will be like -5. If we're going to hit -5 pixels from the box or plus, you'll see in a moment when I'll start drawing stuff. So Y prediction, top or bottom, like if you're going to hit the hitbox from top or bottom. So yeah, that's how you do it. You want to check collision between this, and you want to predict the collision from the left or right by this value. Maybe you don't want to from left or right, so it will be 0, or top or bottom, or maybe 0. Let's go to Paint and do stuff. So this here is our ledge, and this here is our player. We will need to use get sprite in box. So it gets the sprite. You want to check that in this box, x1y1, x1y1, x2 y2. So I'll show you what this function does first. So this is x1 y1, this is x2 y2. It will draw, well, behind the scene it will draw this rectangle between them, and that's the entity we want to check collision with. So if it's inside the rectangle, the imaginary rectangle we created, like it can be this rectangle, let's say this can be the sprite, and that's the bounding box we wanted to check, like to be like bigger than that, like we wanted to check collision from this, and that's one way. Well, that's basically how you do prediction. Like here we predict if it will hit from anywhere around this entity. So yeah, that's how it works. You give it the x1 y1, x2 y2, and it creates the bounding box and checks if your entity, the ID you gave here, the entity ID you gave here, sprite ID, is actually inside that bounding box. So in this case we check get sprite in box, this sprite ID, inside this box, which will be the sprites X, and for the x1 y1, and the sprites X plus width and height plus Y for the x2 y2. So that will create this. But we want to check collision from the left, like we want the bounding box to be like that, like a little bit to the left of the ledge, and then we're going to check. Let's make a smaller selection. We want to check if the player hits from here before it gets into the ledge. We want to check collision from the left. Like that would be, let's say, the x1 will have to be the ledge's x, let's say it's 50, minus 20. So here is 20 pixels before the actual ledge, and if we hit here, it means we're going to hit the ledge from the left. And then we can also predict from the top, same way. Like if the player will hit from the top, or from the bottom, or from the right side. Just a second. Okay, I'm back. Let's see, where were we? So I was basically showing you how it prediction works. What we will actually need is to check, like if the player moves, we'll need to check like hit prediction from, when we'll get to it I'll show you, but basically for each 1 pixel it moves until it hits the box, then it stops the velocity. But for now let's start from the hit prediction. So I hope you understand how it works. Let's try it again. From the bottom, predict from the bottom, predict from the top, predict from the left and the right. So basically we'll need to change the size of the rectangle, the hitbox rectangle, to check if it's like from the bottom, top, left or right or whatever. So let's do all of this with code. Let's see. So first we'll have the return value. By default it's 0. If it's 0 it means no collision have happened. Let's see. The sprite x2, it will be the sprite x of this as float. Same for y. So these will hold the x and y of the sprite with this ID. We'll use get sprite position x with this ID to get its x, and the same with the y, get sprite position y. And we'll need width and height, the width and height of our bounding box. Width and height, so it will start from ID2, from here. ID2, the sprite we want to check the collision with, like the player with the ledge. So it will start from its x and y to its x plus width, y plus width, plus height, to create this bounding box. And yeah, AppGameKit already has this, but this way we can do sx2 minus 5. So now the bounding box will start from here, and we can check collisions from the left. It's minus 5, yeah. So let's populate these variables. sx2 equals get sprite x of ID2. Same for the y. And width is sx2. Oop, forgot to change it to y. sx2 plus get sprite width. AD2. And it's the same for the height, just with Y and height, and the SY2 and plus height. Y2 gets sprite height. Okay, so now we have all the data to create our bounding box. Oh, one thing I forgot. Minus X prediction minus Y prediction. So basically, let's say we have X prediction of minus 10. So it will go from here to the width, like the x2, the x2 here. x2 will be sx2 plus width minus xp, x prediction. So because it's minus here, it will be minus 10 equals 10. 2 minuses makes positive. So the second, the width will be x plus width plus 10. So now that's the prediction from the left side. So basically, that's all you need. So let's make if get sprite in box id 1 is inside sx2 sy2 width and height. If that happens, return 1. So if sprite1, the player, is inside sprites2 bounding box minus our prediction, minus or plus depends, like if you do minus 50 it will be plus 50. Yeah, basically the player is inside this bounding box, which is the ledges in AD2. We'll use it for ledges. The AD2 bounding box plus the minus the prediction. I showed you how it's done here, like this, like that's a prediction from the right. Like if you come for here and you get inside the prediction, you'll get a collision, instead of if you go into the red and only then get a prediction. So yeah, I'll search on Google for stuff if I can show you more examples other than mine. I don't remember where I learned it. It's a very good tool. Flashpunk had it by default with a collision detection. You had to put 0 so it won't predict from anywhere. Like if you want to use it as a regular hit detection. Let's see. I think that's yeah, I think that's enough for one lesson. You should be able to, you need to process this. So we'll need that to predict where we hit the ledge, so we'll be able to stop the velocity. Yeah, before it hits the, well, from anywhere it hits the ledge. Like if you hit the ledge from the bottom, left, right, like in any other way, like how would you do that? Like collision with the ledge happened. From where did you hit the ledge? Top, bottom, left, right? So let's say you're moving from the left to the right and you hit the ledge from the left side. So AppGameKit tells you there's a collision. How do you know if it's a collision from the top, bottom, left or right? The answer, this function, can tell you, because here you check, let's say here this will be 10, so it will be prediction of 10 pixels from the top. So if the player hits from here and he's in here, you know he came from the top, and only from the top. Yeah, basically. Well, there will need to be more logic. I'll show you but that's the key function we need. Okay. I think that's it for this lesson. If you have any questions, you can contact me via the comments, my contact form, the App GameKit forum, or any way you can reach me. That's it for this lesson.